Two already. Can we start class? Can? All right. So, Assalamualaikum and a very good evening. Right. So finally we've met in our 5th tutorial. You guys have your lunch already? Yeah. Okay. Yeah. Nampak letih saja. Okay. So our previous class we have covered for T-test, right? So before that, may I ask, you guys have already installed your SPSS in your laptop? Yeah? Yeah. Okay. So very good. So previous class we have covered on T-test in which we want to compare the mean. Okay, if you conduct a research study, and then for your research objective, for example, you have to compare means between two variables, you use T-test. Okay, but now, okay, for today, the same, we want to compare mean, but using Anova, analysis of variance. Okay, what is the difference between T-test and Anova? Why you use T-test? Why you use Anova? Basically, it is the same, but the difference is your independent variable, okay, your independent variable have maybe more than 2 levels. For example, for T-test previously, you use independent variable, you use, for example, gender. You have male or female. So 2 level or 2 category. But now ANOVA, you might have more than 2 level or more than 2 category. For example, ethnic. Okay, you have what? Malay, Chinese, Indian, Bumiputra, right? So if you have more than 2 level or 2 categories, you cannot use T-test. You need to use ANOVA. Okay, so I may repeat. ANOVA and T-test, okay, you use to compare means. Okay, the same thing, you have independent and dependent variables, but the difference is for ANOVA, you need to use when your independent variable more than 2 level or 2 categories. For example, you have 3, 4, 5, and so on. Okay. Example just now, ethnic. Okay, T-test for independent, you use, for example, gender. All right. So for ANOVA, actually, for your level, you may cover 2 types of ANOVA. Okay. Next week, for if I'm not mistaken, you will cover ANOVA in your lecture hall. Okay, lecture class, which is one-way ANOVA and two-way ANOVA. Okay, actually ANOVA, there's a lot of ANOVA tests. For example, MANOVA, but you not cover on that part lah. We just cover one-way ANOVA, two-way ANOVA. So for today, we may cover on one-way ANOVA. Okay, so one-way ANOVA. This is a simple notes for ANOVA that I have write for you. If I'm not mistaken, I have upload in ITEL, right? Okay, and also your Telegram. So one-way ANOVA. Okay, for you to do the one-way ANOVA, you may have the requirements. Can you see? Or we need to enlarge a little bit more. Can I enlarge? No need. All right. So the requirement, first, your samples, okay, your samples or your data that you have obtained, they need to be normally distributed. Okay, where can you see? You need to look at the homogeneity of variance. We will look at the homogeneity of variance afterwards in your SPSS, okay, in your output. Another requirement, the measurement scale of, this is important, interval or ratio for the dependent variable and nominal measurement scale for independent variable. Just now I have mentioned for you, independent variable may consist of more than 2, which is 3 or more level or the categories. For example, just now ethnic, right? Okay. So we go to the example. While we look at for our tutorial, the first example here, you may open your SPSS. You do the practice. Open your SPSS right now. Open your laptop, open your SPSS. Okay. If you just take a look, then you will nothing. Yeah. For those who have problem install your SPSS, you can use PC. But for this role, cannot. I don't know why. Yeah. All right. We go to the example one. If I'm not mistaken as well, in your ITEL, I have upload example of data for SPSS as well. Data set. Open that data set. Okay, we go to the example one. Okay, we have two examples for one-way ANOVA. Example one, we have example for the case study. Okay, why we need the case study? Okay, you just imagine you have conduct a research. Okay, you have conduct a research. Your research is quantitative. Okay, either you have qualitative or quantitative. Okay, if you use SPSS, okay, means your study is quantitative. Okay, not quality lah. All right. So your research has been conducted. You use quantitative. Your research instrument, you use questionnaire. Right? You distribute to the student. You distribute to the, I don't know who are your respondents. Okay, you have distribute your questionnaire and then you obtain your data from the questionnaire lah. Okay, so you obtain your data. You have what you call transform your data into your SPSS. Okay, and then what you need to do, you want to look at the research objective. For example, this is one of your research objective. In a research, you might have 2, 3 or more. Okay, for your level, undergraduate level, usually 2. Okay, but sometimes they do 3. Depends on you lah. So maybe this is one of your research objective. Okay, your research objective, for example, I write to determine the significant difference in the level of happiness. Okay, based on 4 different ethnicities. Okay, you have 2 variables there, one dependent and one independent. Your dependent variable is level of happiness. Independent is your ethnicities. Okay. From this research objective, okay, you have discovered. Okay, you have discovered your, this one I write in Malay because based on your SPSS data, it is written in Malay. So I write tahap kegembiraan. Second one is ethnic. Okay, from this research objective, you need to come up with your inference or your null and alternative hypothesis. Okay, you need to have null and alternative. Why? Because at the end of the day, you need to know whether there is a significant difference or not. You want to know. That's why you need to have your hypothesis. Your null hypothesis, HO here is null hypothesis. Okay, abbreviation for the null. It is stating that there is no significant difference. Tiada perbezaan. No significant difference in the level of happiness based on 4 different ethnicities, meaning that Malay, Chinese, Indian, Bumiputra, their level of happiness the same. I'm happy, everybody happy. unsaid. Everybody said that is the null hypothesis. H1, alternative hypothesis. There is a significant difference in the level of happiness based on 4 different ethnicities. Okay, meaning that, for example, this is not racist class. We are talking about ethnic. Okay, that's why I'm mentioning Malay, Chinese. Okay, oh, doctor is Malay, I'm Chinese. Why saying Malay? Yeah? No. Okay, we are talking about ethnic. Say, for example, this alternative hypothesis, there is significant difference in level of happiness. Might be Malay is more happy than Chinese. We don't know. Okay, that is what it states there. All right. And then you have, or you already have your hypothesis. Make sure you have null and alternative ones. Okay, because you need to know. At the end of the day, you need to reject or accept. All right. So now we run our SPSS. Okay. First, okay, you already have your case study. You have already your research objective, hypothesis. Now you want to run your SPSS. Okay, what variable that you want to insert? Okay, this one we have stated here, dependent and independent variable. So please go to your SPSS. Okay. Macam mana ni? Okay lah. Alright. So first, okay. First, go to analyze. Click analyze on your SPSS. Okay. And then you want to compare means, right? Okay. Try to find compare means. And then go to one-way ANOVA. Click. Okay. So you will have a pop-out, okay, on your screen. Okay. So this pop-up, you can see you need to insert dependent list and also factor. Okay, bear in mind, factor here, okay, factor here is independent variable. Okay, so your dependent variable just now is what? Level of happiness. Level of happiness kah? Kan? Tahap kegembiraan. Alright. Mana tahap kegembiraan here? Alright. So, okay. Here you can see tahap kegembiraan or level of happiness. It is in interval or ratio. Okay, just now I have mentioned interval or ratio. Okay. So, click here. So you have put the tahap kegembiraan under dependent list. Okay. Meanwhile, another one you need to put ethnic. Okay, because your research objective, you are looking for 4 different ethnic. So you put under factor. Okay. And then next, okay, you have put your dependent list, level of happiness, and then factor, ethnicity. You have put these 2, and then click option. Click option, select descriptive homogeneity of variant test and means. So click option on the right hand side. Okay, you have pop-up option, click. And then you need to click on descriptive homogeneity variant test and also means plot. Can follow me? Okay. So if you still remember, in t-test, you should know whether your data is normally distributed or not, right? Normal distribution means that your data is normally distributed, means you can use parametric tests. Your parametric test, if you want to compare means, if you recall, if you want to compare means, you can use t-test. If your data is normally distributed. If not, you cannot use parametric test. Okay, so here, this is one of the way that you can see your data is normally distributed or not. Depends on what? Depends on homogeneity of variance test. Afterwards, we will see the significant value. All right. So you have clicked these three, then continue. All right. And then what else? Click continue. Okay. All right. So click continue. Okay. Okay, wait for the output to come up. Okay. So this is the output. Okay. This is the output. So first you can see what? You can see the mean value. Okay. Here it is stated the mean and the standard deviation value for this ethnic. Okay. You have Melayu, Cina, Bumiputra. All right. So from here you can compare which mean is the highest. Okay. So if you look at here, the highest will be which one? Melayu, Cina, India. The mean, if you compare, which one is the highest? Come on, guys. This is only math. Bumiputra. Very good. So 3.06. Okay, the mean value for Bumiputra is 3.06, which is it has the highest mean when you compare to Cina and Melayu. All right. This is just the statistic. Okay, statistic number. Then, okay, what else? We go to the next. Okay, this is the same. This output is the same. I just screenshot from the output just now. I just screenshot. Okay, next you go to the test of homogeneity of variance. Okay, look at your test of homogeneity of variance. Here, okay, look at the mean. Here, mean, the significant value. Okay, this is how you read mean significant value. We are looking for what? We are looking whether our data is normally distributed or not. Okay, to confirm that, can we use Anova? Can we use Anova to compare means? Then look at here. Okay, your significant value, whether P is more or less than 0.05. Your value here is 0.08, meaning your significant value is more than 0.05. If your P is more than 0.05, your data is normally distributed. Okay, your data is normally distributed. Then you can use Anova. Here, I write already in your words. Normal data can use Anova. Okay, so meaning your P more than 0.05, your data is normal, you can use Anova, settle. Okay, so after that, if you have confirmed that, oh, I can use Anova, then you can look at your Anova table. Okay, the next is Anova table. The same, it is the same from your output. Okay, we look at here. From Anova table, okay, from this Anova table, what you need to see is that, please look at the significant value. Okay, look at your significant value, whether it is more or less than 0.05. Okay, please take note. Please take note. If the P value is more than 0.05, your null hypothesis should be accepted. Or in other words, you say that HO is failed to be rejected. What is your null hypothesis? Just now, look at your null hypothesis. Yes, you say that there is no significant difference, okay, in level of happiness between the 4 ethnicities. We are happy, all of us, okay? So it is no significant difference. Why? Because based on the Anova table, you say that the significant value is more than 0.05, meaning that your null hypothesis is failed to be rejected or accepted. Okay, so you write your conclusion. Based on the findings obtained in one-way Anova, the level of happiness for 4 different ethnic, okay, F is here, AF, freedom, 2. 2 here is degree of freedom. Where can you get the 2 here is from DF. Here, DF. Okay, this is how you write. DF, 2, you write in the bracket, equals to 0.328. Where did you get 328? Is from the F value, the freedom value. Okay, this is your value for the Anova. Okay, so from here, you can say that, okay, from the significant value 0.721, okay, 0.721 here, 0.721, it is more than 0.05, okay, therefore, the null hypothesis, what is your null hypothesis? You state that there is no significant difference in level of happiness for 4 different ethnic, and it is failed to be rejected. Okay? Faham kan? Okay. So this is the condition where, okay, this is the condition where your significant value for Anova is more than 0.05. What happens if your P value or your significant value here less than 0.05? What would happen? Null hypothesis will be rejected, right? Meaning there is significant difference of level of happiness between for 4 different ethnic. So what you need to do next. This is example number 2, where your P value just now less than 0.05. The steps are the same, okay, but there's another thing that you need to click on SPSS, okay? So example 2, you have your case study. Okay, you have your case study, your research objective are the same. Okay, if you see, it is the same thing, okay? But the difference is life satisfaction. Your dependent variable. Just now is level of happiness. Now is life satisfaction. Are you satisfied with your life? Okay. So you write your null hypothesis. All the steps are the same, but the dependent variable are different. It's just the dependent variable. Okay. Dependent variable just right now is life satisfaction. Okay. You just tukarlah life satisfaction. Okay. Now we run our SPSS. Okay. We run our SPSS. All right. We run our SPSS. For this one, for your output, if you want to save your output, it depends on you. Okay. For me, I don't want. So sombong ah. No, it's not sombong. Okay. Analyze. Okay. The same things. Analyze, compare means, and then try to find one-way Anova. The same thing. You have a pop-out that you need to insert your dependent and factor. Okay. Again, your factor is independent variable. The same thing, ethnic, but the difference is tahap kegembiraan, no longer tahap kegembiraan. You need to find your life satisfaction. Kepuasan hidup. Alright. So you put under dependent list. If you recall, okay, the first example, you click option. Okay, these 3 here. Okay, nice. Continue, but you need to click on Post-Hoc. Okay, you need to click on Post-Hoc. Click to key. Okay, actually there's a lot of tests here, not just to key. You have the Ferroni, you have LSD, you have KP, but as far as I'm concerned, okay, there's a lot of references and it is well known that we use all the researchers used to key in your post-hoc one-way ANOVA. Okay, so that if you discuss on your result, you have references to cite. Okay, so you use to key, you just click to key, continue. Okay, and then what you need to do after you click continue, okay, you click OK. All right. Wait for the output. All right. So you have your output. Okay, as usual, it will give you the descriptive data, which is you have mean and standard deviation data here. So from here, you can see which one is highest. Okay, so you have already, you know that Bumiputra is the highest. Okay, for kepuasan hidup. Okay, previously is not kepuasan hidup. Previously is level of happiness. Okay, so again, Bumiputra, you are happy. You are satisfied with your life. Okay, so test of homogeneity, the same thing. What you need to do, you need to look at the significant value here. Why we need to do the test of homogeneity? You need to know whether your data is normally distributed. Okay, so right now your significant value is more than 0.05. So your data is normally distributed. So you can use parametric test, means you can use ANOVA. Okay, so you can use ANOVA, straightly go to the table for ANOVA. Okay, table for ANOVA here. If you can see your significant value, P is less than 0.05, no longer more than 0.05. Okay, as I mentioned, if P less than 0.05, your null hypothesis rejected, meaning there is significant difference between kepuasan hidup and ethnicities. All right, so after that, what you need to do, I would like to show you this table. This one, the same. I just screenshot. Okay. So from here, what you need to do is that you need to look at the significant value for each of these ethnicities. Okay. Please look at the significant values. For example, you see Melayu and China, they are doing what? They are doing the comparison. Okay, Melayu and China, your kepuasan hidup, is it significantly different? It is 0.055, meaning more than 0.05. If more than 0.05, your null hypothesis, yes, accepted, or failed to be rejected, meaning no difference. Okay, so same goes to Melayu and Bumiputra. Your significant 0.89, more than 0.05. HO accepted. Your null hypothesis is accepted. Okay. Wait. Next, we go to the comparison between Chinese and Malay. Okay, you do the comparison between these two. How about the significant value? The same, more than 0.05, meaning your null hypothesis is accepted. We go to the next, Chinese and Bumiputra. Okay, Chinese and Bumiputra, your significant value is less than 0.05, meaning your null hypothesis is rejected. So there is significant difference between siapa? Between Chinese and Bumiputra. But how much the difference? Look at here. Okay, negative 2.15. Why it has negative there? Okay, the formula is Chinese minus Bumiputra equals to negative 2.15, meaning that Chinese ethnic different from Bumiputra, but less about 2.15. meaning Bumiputra is higher than Chinese, but Chinese is less than Bumiputra, but how much? About 2.1. That's why negative there. If you don't understand, you look at here, Bumiputra and Chinese, the same thing, you compare. But your value doesn't have negative. Why? Because Bumiputra is different from Chinese, but the difference is Bumiputra more 2.1 than Chinese. If you still don't understand, you look at your mean value up there. All right. I said that Bumiputra is higher than Chinese. Higher in terms of what? In terms of kepuasan hidup. All right. So you can see your Bumiputra data here. The mean value is higher than Chinese. Understand? 2.1 just now is what? The mean difference. The mean difference, not the total. This is the total mean for Chinese and Bumiputra. But for Anova just now, the comparison just now, 2.1 is the difference of the mean. Understand or not? Okay, so that is why you have negative and positive. Okay, so you look at here, you can see that there is a significant difference between these two ethnicities, which is Chinese and Bumiputra. Okay, you have no significant difference between Chinese and Malay or Bumiputra and Malay. Your issue here is Chinese and Bumiputra. Okay, so the next table, okay, the last table here, it is actually the same. It is actually the same. It just want to state that, okay, it just want to state that if here 21.72 and 23.52 here is more than 0.05. So means that it is significantly it is no significant difference between the Chinese and Malay. Okay, so this is just the conclusion table. Okay, you can see from up here actually. Okay, from here you have your result already. All right, so this one I think no need lah. Okay, it just the conclusion table. All right, for your conclusion, okay, for your conclusion for post-hoc test, you used to key just now. Based on the findings obtained, it is revealed that there was a significant difference in life satisfaction, kepuasan hidup, based on 4 different ethnicities. Okay, what is your 4 ethnicities just now? Chinese, Malay, and Bumiputra. The life satisfaction for Chinese ethnic, okay, this one you can you can state the mean and the standard deviation. Where can you get this value? From your statistic descriptive table, okay? And had a significant difference with that of Bumiputra ethnic. This is the mean and the standard deviation for the Bumiputra ethnic, okay? From the statistic table. The null hypothesis stating that there is no significant difference in life satisfaction based on the 4 different ethnicities was rejected. Why it is rejected? Because the life satisfaction of students was significantly different based on 4 different ethnicities. Okay, just now you have said that there is the significant difference. Why? Because from the Anova table, you can see it is less than 0.05. Okay, this is your evidence. All right, so this is just report. So you write F, this is the format, F in the bracket of 2, freedom. 2 here is the degree of freedom. Where can you get it? From the table. Equals to 4.552. This is the Anova value. And P is 0.01, which is less than 0.05. That's why you reject the null hypothesis. So it means that there is a significant difference in kepuasan hidup among the three ethnicities. Okay, so that is how you interpret the post-hoc Tukey Anova, one-way Anova. Okay, ada masa lagi? Alright, so what if you have repeated measures? Okay, what if you have repeated measures? In this case, for example, okay, for example, you will do your FYP in your 4th year. No. Oh, you don't have FYP. And then when can you do the research? Oh, okay. Oh, you're different from me, eh? Okay. So you will not do your research lah. May or may not. Okay. We take a positive side. Huh? You may do your research. Okay. You will conduct a research. You just imagine lah. Okay. You may conduct a research. Counseling, right? Okay. Is it the same with the anti-dadah? No. Oh no. Counseling, your respondent will be students or depends. Okay, for example, students lah. You go to the school. These students have problem with the discipline. Discipline, is it? Okay, you need to do the counseling session, for example. Okay, so you try to do a research. Okay, whether this group of students that have problem, okay, have problem in disciplines, you need to know whether there is a difference before and after you do the counseling session, for example. Okay, so you do the pre and post experiment, pre and post test. Okay, whether this group of students will change, have the positive effect after you do the counseling session. If no positive effect, meaning your counseling session is nothing, right? Okay, that's why you need to do the pre and post. So you want to know whether there is a difference. Okay, there is a difference in pre and post. You use Anova for repeated measures. Okay, so for one-way Anova repeated measures, okay, this is your case study. Okay, this is your case study, your research objective. You want to determine the significant difference in life satisfaction. Okay, life satisfaction, kepuasan hidup between pre-test, post-test 1 and post-test 2. Okay, this one I just get from your SPSS data set. Post-test 1, maybe they have another alternative method which come up with the post-test 2. I don't know. So they have 3, yeah? All right. So after you have your research objective, you will need to state, as usual, you need to state your null and alternative hypothesis. All right. Your null meaning you need to say that there is no significant difference in life satisfaction between these three. Okay. For alternative, there must be a significant difference, right? As usual. So run your SPSS, right? What you need to do, it is different. It is different from the one-way Anova that from the first and the second example just now. Okay. No longer you click compare means. So what you need to click, general linear model. All right. Go to your SPSS. I don't want to save. Go to your SPSS, analyze. Okay. No longer compare means. Look at general linear model. Okay. Because we are doing repeated measure, then you need to choose repeated measures. Okay. Why repeated measures? Because you are doing pre and post tests. Okay. So for within subject factor, okay, just now your dependent variable is what? Kepuasan hidup, right? Life satisfaction. So you need to write life satisfaction. But bear in mind, for naming, you cannot have space. So you need to do whatever lah. Satisfaction. Do not have space. Okay. Like underscore like this. Okay. Life satisfaction. Number of level. How much you have free. Post 1, post 2. So 3, right? Okay. So 3. So add. Okay. Already here. So click and then you need to do what? The next step here. After you add, you click define. Okay. Click define. Define. Before you click define, make sure you click here life satisfaction to ensure your define here is pop up. So you click define. What you need to do, you look at within subject variables. You have 3 here with the question marks. So what you need to do, you need to click on what you need to analyze. So the first one is kepuasan hidup pre. Insert. Kepuasan hidup post 1. Insert. Kepuasan hidup post 2. Okay. So you have insert these 3. All right. So what you need to do next, after you insert your variables here, you click option. Click option and then click descriptive statistic, click estimate of effect size, and click observe power. Okay. So option, descriptive statistic, estimate effect size, and observe power. These 3. Okay. Settle. Continue. All right. After you continue, you click OK. Right. This is the last step. Okay. Wait for the output. All right. So you have your output already. Okay. As usual, they will give you the mean value first and the standard deviation. Okay. From here, you can see which one is highest and which one is the lowest. So you can do the comparison already actually from the descriptive statistic table. Okay. But we don't want to see on that value. We go to the next. Okay. I just show you from the words lah, much bigger. So from here, you have how to spell this. Mokley's test sphericity. Okay. So from here, you have a significant value. Okay. Your significant value for the life satisfaction for the 3 repeated measures is less than 0.05. Okay, it is less than 0.05, meaning your null hypothesis is rejected. So what is it means? It means that there is a significant difference in life satisfaction for pre, post 1, and post 2. Okay, so look at the conclusion. It is quite easier lah. Okay, look at the conclusion. Based on the findings obtained in the one-way Anova table, okay, it is repeated measures in bracket. The life satisfaction between pre, post 1, post 2 showed F2, 2 is degree of freedom. Here, degree of freedom is equals to 0.741. 0.741 is where Mokley's W here, 0.741. Okay, and the P, which is the significant value, is less than 0.05. The evidence is here. Okay, less than 0.05. Therefore, the null hypothesis, which it states that there is no significant difference in life satisfaction between pre, post 1, post 2, is rejected. When I said null hypothesis is rejected, meaning the life satisfaction of students between pre, post, and post 1 and post 2 are significantly different, with the mean score from This one is from your descriptive statistic table. Okay, the mean different from 22.99 to 23.13. This one from your descriptive statistic table. Let me show you. Here. Okay, you get the mean value here. Okay, so you need to report in your, if you do the research lah, you need to report in your study. Okay, this is how you report in your study. All right, so based on these three, okay, based on these three, you can see that the first one, okay, one-way ANOVA for the first one, when your condition is where your significant value is more than 0.05, you are saying that the null hypothesis is accepted or failed to be rejected. Okay, for example, 2 one-way ANOVA just now, if your significant value P is less than 0.05, your null hypothesis should be rejected, meaning there is a significant difference, okay, in these two variables. So if there is significant difference, what you need to do? You need to click on Post-Hoc. Okay, Post-Hoc test, click on to key. Okay, from there, you can have your table. Okay, you can have your table here. Okay, if you see here, actually you already have your ANOVA table, but because of HO is rejected, okay, because of HO rejected, you are saying, oh, these two variables, they are significantly different. But how? How different are they? That's why you need your Post-Hoc table. In detail, you need to see how much the difference. What is the difference between what and what ethnic? How much the difference with the mean? That's why you need your Post-Hoc. Okay, otherwise you cannot report. Okay, so the third one is if you have repeated measure. Okay, repeated measure means if you do experiment, for example, just now you are doing counseling, you have pre-post, right? So if you have the pre-post, you need to do compare means using ANOVA repeated measures. Okay, so the important here is that you need to know where to click. Okay, where to click. If you do the one-way ANOVA, where to click first? Is it analyze? Is it transform? Okay, and then after that, what you need to click, what you need to insert. Okay, and lastly, how to read the table. Okay, so I think that's all. Any questions? No, huh? Okay, but please make sure first. Okay, please make sure first before you do ANOVA, before you do t-test, your data should be normal. Okay, if not normal, you cannot do parametric test, you cannot do ANOVA, you cannot do t-test. Okay, so that's all, I think. If there is no question, then thank you. That's all lah. And also, this class actually I record because of your friends tak ada air, kan?